All right, hello chemistry students. We are trying to solve for an empirical formula. All right, so a sample is found to be 44.4% sulfur and the rest is oxygen. Determine the empirical formula. So if you already got the practice of this down, maybe pause it, try it, otherwise we're gonna work through it. All right, so if it's 44.4% sulfur, the rest is oxygen, we can just do 100 minus 44.4 to determine the amount of oxygen. All right, now the first step we're gonna do is we're gonna assume we have a 100 gram sample. If we assume a 100 gram sample, that means we have 44.4 grams of sulfur, and we gotta do 100 minus 44.4 to figure out the percentage of oxygen. So this means we have 55.6% oxygen, and if it's a 100 gram sample, 55.6 grams of oxygen. So now the second step is we have the mass. We're going to divide by the molar mass to get the moles of each element. So for sulfur, we're going to use 32 grams per mole. So we're going to do 44.4 divided by 32, and we get 1.39 moles of sulfur. Now for the oxygen, we're going to divide by 16 grams per mole. So 55.6 divided by 16, we get 3.475 moles of oxygen. All right, so these are the moles. Now, because they're both in the unit mole, which is a counting atom, it tells us how many atoms, we can take these number of moles and temporarily make them the subscripts. So S 1.39 and O 3.475. All right, the subscripts should be the simplest whole number ratio between the two atoms, between two different elements, and this is kind of yucky. So we're going to divide both by the smallest number. So we're going to divide both by 1.39. All right, anything divided by itself, sulfur should become 1, and it's the oxygen we got to check. So 3.475 divided by 1.39 gives us 2.5. Now again, we need a whole number ratio, so what we're going to do, we're going to multiply both subscripts by 2, all right? And that's going to give us our final answer of S2O5. All right, so we assumed a 100 gram sample. We got the percentages to become masses for both the sulfur and oxygen. We took their molar masses into account. We solved for the number of moles of each. We set up the moles as the subscripts. We divided by the smaller one. That gave us SO 2.5. Because we had that 0.5, we multiplied until it was whole. In this case, we multiplied by 2, so we got S2O5. All right, that's an empirical formula from percentages.